Sky This Month with your host, Dave McDonald.
Welcome to the Sky This Month. I'm your host, Dave McDonald, and this is November 2023, and another great month for observing in the night sky. We have a meteor shower coming up to talk about. We've got planets in the evening, at least one good planet in the morning, and so many things to talk about. But first, I'm wondering if you have seen the October 14th eclipse. So last month, October 14th, at Belmont, Bryant Field in Belmont, I had my astronomy club there. And so we hosted probably 40, possibly 50 people came. And if you remember, it was a mostly cloudy day. But we had enough breaks to see the beginning of the eclipse, a little progression, the maximum period of the eclipse, which is about close to 20%, and the eclipse on its way out. So we had reasonable breaks and a good audience, eclipse glasses. We were able to donate some money to the Maui Relief Fund, and you can see the images on your screen that Parker took through two different telescopes. The one on the left, you can see, had a slightly more yellow to orange type of filter, but not only can you see the eclipse, where you see the shadow of the moon coming in over the sun, but you also have right here and right down here some very nice sunspots that were able to be seen. And over to the right, slightly different, a little more, just a little more of the moon coming in on the sun. Different telescope, so it's just a different angle where he used his cell phone. Parker took these pictures. And again, you can see the sunspots very nicely here. And you can make out the wispiness of the clouds going by. So I thought these were really good representative pictures of what we saw on October 14th. I hope that you got a chance to see it as well. So, as I mentioned, we have a meteor shower coming up, and in a moment, we're going to be talking all about meteors and the Leonid meteor shower, which is the feature meteor shower of November. And we've got planets in the morning. You got Venus. I'm not going to show you an image of Venus, but Venus and the moon are going to pair up November 9th, a nice waning crescent moon with the planet Venus. That's going to be the morning, a couple hours, an hour before sunrise, a nice crescent moon with the planet Venus blazing at negative 4.7 magnitude. You can't miss both of them. And binoculars, of course, it just makes the image nicer. Mercury, not very handy in the November sky, and Mars is lined up in conjunction with the sun, so Mars and Mercury aren't going to work out so well. But a little later in the show, I'm going to show you where you can find Saturn and Jupiter, and because they're kind of the stars of the evening program, and as well as the Leonid meteor shower. So let's talk about some planets. So here are the planets kind of lined up. They never really line up this way, but this just makes it easier for the textbook companies to get it on a page or possibly a fold-out page. So you have the planets from Mercury out to Pluto, and I'm so happy that finally somebody realizes that Pluto is a planet. So it's a dwarf planet, yes, but that's a new classification. But we have Mercury, Venus, Earth, and Mars are terrestrial planets. They're planets. And we have Jupiter, Saturn, Uranus, and Neptune. They're in a class called Jovian planets. They're planets. We have a new class, which is perfectly fine, called dwarf planets, of which Pluto is the largest member, but Pluto's a planet. Well, we're going to talk about right now the brightest planet in the night sky, and that's Jupiter, right there in the middle, number 5 from the sun. About, as a matter of fact, 5 times further from the sun than Earth is. And this image is not to scale, neither the size of the planets nor the distance from the sun. It just shows you the lineup in the correct order. Well, Jupiter has a circumference of, that's around, right, around its equator, 273 just about miles. The diameter, 88,000 plus, just about 89,000 miles. And a volume, if you want to consider, well, how much stuff could you put inside Jupiter? 343 trillion cubic miles. A cube, of course, length, width, and height. And a tremendous mass. The density, however, is about 4 grams per cubic centimeter less than Earth. Earth is around 5.3 grams per cubic centimeter, and Jupiter is a mere 1.33 grams per cubic centimeter, but it is really, really large, so it has a lot of mass. And we're about 5.2 AUs, and then the AU is the distance from the sun to the planet. And in this case, we're talking the sun to Jupiter. But 1 AU is the distance from the sun to Earth, about 93 million miles. And so you can see here, we've got 483 plus million miles from the sun, or again, about 5 times further than Earth is from the sun. And so in this image here, you can see the number of Earths that will fit across the face of the planet Jupiter, basically edge to edge or across the diameter. And 11 Earths can fit across the diameter of Jupiter. And you see this item right down here. This is the Great Red Spot. And if we have a close-up here, you see, and I use my red laser pointer, perhaps you can kind of judge that it's about 1.5 Earths that make up this great, tremendous storm. 400-ish mile-an-hour winds that are continually going. And you know, we've had some large hurricanes here on Earth, and they seem to be getting bigger on average. But you think of Katrina, for example, 1,000 miles in diameter. It was a huge storm. Can you imagine a storm that's 12,000 miles in diameter, like on the planet Jupiter? But an interesting thing, we have the Juno mission at Jupiter, and the Juno mission is spelled J-U-N-O, and you can look it up, you can Google it and find out more information about it, but it's right there at Jupiter right now as we speak. And one of the things it's studying is the Great Red Spot. And the data that is being received and processed is indicating that that Great Red Spot is shrinking. They're not sure why, but there's trending that could possibly lead to the disappearance of the Great Red Spot by the 22nd century. We'll see. Mark it on your calendars to check it out. It's a gas giant. There's no solid surface, so if you flew to Jupiter on your rocket ship, you can't land the rocket ship and you can't get out and walk around. It's comprised of 7 different gases. Most of it, just about 90%, is hydrogen. And then another 10%, which is just about the whole bag, is helium, with some methane, ammonia, hydrogen, deuteride, ethane, and some water vapor, a very small percentage. It has a magnetosphere. It has a very strong magnetosphere. And the Juno mission, as a matter of fact, is well insulated from the magnetic disturbances as well as the radiation that it's receiving in orbit around Jupiter. An interesting factoid is that Jupiter generates more heat from its interior than it receives from the sun. Who knew? This image of Jupiter shows an aurora at the poles. And this is, again, largely due to the interaction of the solar winds. The particles from the sun do get out to Jupiter and interact with its magnetosphere that we were just talking about and creates the aurora. So this is an actual photograph that shows the aurora at the North Pole on Jupiter. And you can see another nice image of that great red spot. If you're looking through a telescope and it's not there, if you wait a few hours, chances are it will appear, as Jupiter makes one rotation in just under 10 hours, about 9 hours and 55 minutes. And it's a huge planet, as we've already seen, and it rotates very, very quickly. So if the great red spot isn't there through a telescope and you're looking for it, if you wait 2 or 3 hours, it probably is going to appear for you. It definitely is going to appear in 5 hours, but hopefully it's on its way in rather than just left. Okay? Now, I always wonder about moons. Jupiter used to be the king of the planets. When I was in elementary school, Jupiter had 12 moons. Well, we're up to 92 plus moons. And some of these moons are, even though like sports stadiums, like Gillette, right? Gillette Stadium, where the Patriots play, Fenway Park, not quite as big. But some of these moons are that size. Now, those venues are large, but when it comes to calling something a moon, not really that big. But the big moons for Jupiter are the Galilean moons that Galileo himself discovered with his telescope that he pointed towards the heavens. And when he got the optics good enough, he noticed that there are 4 items that seem to be orbiting Jupiter. And remember, the thought of the day was everything orbited Earth. So this is one of a few things that got Galileo in trouble with the church in noting that, well, actually there are other things orbiting something else, and the something else, Jupiter, is not orbiting Earth either. It's orbiting the sun. So it's crazy. Now, even though Jupiter doesn't have a surface that you can get out and walk around on, it does have gravity. It has a very attractive force because of its great mass, low density, but there's a lot of it. So you have about close to 2.5 times the gravitational pull as we have here on Earth. So on Earth, 9.8 meters per second square is the acceleration, and then we have on Jupiter, almost 24.8 meters per second square attraction of pull of gravity. And just as a side note, we were talking about moons. Saturn, 146, as of June, okay, June 2023, the number probably is larger. Again, I find it interesting how large or how small they consider a moon to be, but last count that I looked up in June was 146 moons. Wow. I can say that backwards. Wow. Now, I mentioned the 4 Galilean moons, and these are they. We have Io, and if you're looking at a picture of moons and you see something that kind of looks like a pizza, well, that's Io. Io kind of looks like a pizza. It's the smallest of the 4 Galilean moons. Europa, one of the claims to fame of Europa is that it has under ice oceans of water, liquid water. And someday we'll be sending, in the not too distant future, it's called the Europa Clipper that is in the design and construction phase, is going to be going to Europa to investigate this. Because underwater oceans, who knows what that might mean. And that's one of the reasons that, if you remember back to 1994, the Galileo spacecraft was intentionally crashed into Jupiter so that when it ran out of fuel and it could no longer be guided, they intentionally crashed it into Jupiter so it wouldn't go rogue and accidentally land on Europa and possibly some hitchhiking microbes or bacteria or something would take up colonization on Europa. So anyway, we're going to be investigating that. Callisto, if you're looking at pictures of moons and you see one that looks like our moon, chances are it's Callisto. Callisto looks similar in nature to our moon. And then the giant of all moons is Ganymede. So there's your 4 Galilean moons: Io, Europa, Ganymede, and Callisto. All right. Hope you enjoyed that little chat about Jupiter. And later on in the show, after we talk about the meteors, I'm going to show you exactly where you can find Jupiter in the night sky. And it's not hard to miss. I should say you can't miss it, because it is the most brilliant object in the night sky, unless the moon's in the area, which it's going to be when we get into mid to later November. But now let's transition and talk about the meteors. The meteors are coming, and so we're going to talk about the variety of different meteors that there are. And I just want to give a little credit to John Blackwell, a colleague of mine who helped me gather these images and put this program together. So we hear of shooting stars, we hear of falling stars. Stars don't shoot. Stars don't fall. They do die, but they don't shoot or fall. So really, meteors are small grains of dust and debris from the early stages of our solar system. And meteor is from the Greek word meteoron, which means phenomenon in the sky. When people looked up, can you imagine the first people that looked up before it was a known thing that these things happened regularly? It's like, are the stars shooting? They don't have any equipment or instruments to say anything different. Well, 3 words. Meteoroids, that's the dust and the debris that is floating around in our solar system. They're called meteoroids. Meteors are the meteoroids that have collided with our atmosphere. They create friction, they burn up, or if they are too large to get burned up and consumed, and the meteors, again, fall, not stars, but the meteors fall to Earth, then we call it a meteorite. And these are meteoroids that were large enough to actually land on Earth. And interestingly enough, there have been no meteorites ever found in the state of New Hampshire. There are a few other states where that's also true, smaller states, as you can imagine. The more real estate you have for a state, the more likelihood you're going to have some meteors come your way. But no meteorites have landed in New Hampshire. We've had a number of samples brought to the McAuliffe-Shepard Discovery Center for myself and other of my colleagues to look at to determine if they're meteorites or not. And we have determined that they are, in fact, meteorons. Okay. So they're about the size of a grain of sand, a tenth or so of an inch. And they give off a large amount of energy that is enough to power a 100-watt light bulb for a couple of seconds. And the larger ones are maybe a whole millimeter wide and pack a punch of like a .22 caliber bullet. Most meteors are comet debris. So where do these dust grains come from? Well, they're outer layers of comets, and that shed their material, and that material from the tail of the comet continues to orbit Earth. We'll talk about it a little later. So these are everywhere in, so to speak, the dirty parts of our solar system. And again, most are like the consistency of dust bunnies, no larger than a grain of sand. And as they're in space, they're meteoroids. And then when they land, they're meteorites, and they're meteors if they just interact with our atmosphere. And we have 2 major types. There are stony and iron. 90% of them are chloridites, and they are 90% of the types that you find, and they're stony ones. And then about 10% are iron. And one way that you can tell if you have an iron meteorite, if you find something that looks like it on the ground, is get a magnet. Does a magnet attract it, or is it attracted by a magnet? And that's one way to determine the possibility or the probability of it being an iron meteorite. They really come fast. And so how is it if they're really so high up, like 60 miles or so up, where they start interacting with the atmosphere, Why is it that we see them? Well, they're hitting the Earth's atmosphere 25,000 to 160,000 miles an hour. And this friction, or this ram pressure, releases this flash of energy. So it's not really so much it's burning up as it is the ram pressure releasing the flash of energy. And so sometimes the flashes are really, really intense and can be seen hundreds of miles away, and the particles usually disintegrate, but every once in a while you get what's called a bolide, or a meteor like what you're seeing here. But every once in a while it makes it through the atmosphere, and in this case, in Peekskill, on October 9th, 1992, it made it through somebody's garage and hit their car, and Chevy Malibu. It was a 1980 Chevy Malibu, and when Mrs. Knapp investigated a crash outside her Peekskill home, this is outside, not in her garage, and she found a damaged trunk and a warm 12-kilogram meteorite. So that's about 30 pounds, roughly, lying beside her car. It happens. I believe the car is in a museum somewhere, and worth a lot more than she paid for it. Fireballs, really, really bright ones, about the diameter of a marble. And some of these have energy like a Volkswagen Beetle going 60 miles an hour. It's crazy. And you have a couple of different types of meteors, sporadic meteors, and you have here a shot of the 1966 Leonid meteor storm, where there's just all kinds of meteors that are happening. Some other images of meteors. The big one, again, in November that we see is the Leonids. And every now and again, you can go out on any night and you might see one that we would call a sporadic. And you might see a couple of those on any given night that don't particularly belong to a storm. So the ones that are related to a particular meteor shower are regularly visiting meteors, and they are in orbit around Earth because a comet left its trail of dust. And if you can see here, we have the orbit of Earth and we have the orbit of a comet, and that orbit of the comet intersects the orbit of Earth, and every time the comet goes through, which may be frequent or infrequent, it leaves a trail of dust. And then when Earth comes around in that period of time, at that same time every year, it passes through that trail of dust. So the comet responsible for the Leonids is Tempel-Tuttle. Tempel-Tuttle. And again, you can see here the orbit of the comet coming around, passing through the orbit of Earth. And so around November 17th, Earth passes through the debris trail left by Tempel-Tuttle. And they impact, really, as we said before, really, really fast. They look for storms every 33 years or so, but in looking forward from now, it may not be until about the 22nd century before we get another meteor storm. Here's a bright bolide going through, and they appear to come from a place called the Radiant. The Leonid Radiant is in Leo, thus the name Leonid. And you see the sickle of Leo here, which I'm going to show you in just a moment. And that is where the meteors seem to be coming from. So you see what those red arrows are. You can see those faint trails, some of them over on the right are a little brighter. And if you can see, let me just choose this one for example. If you trace that backwards, you see it ends up in a place we call the Radiant, the one over to the left, which is fainter. But if you trace that backwards, it seems to come from a point in the sickle of Leo, the same place where the Radiant is located. And that's why it's called the Radiant. Time lapse here, you can see star trails happening and some bursts. But they notice, again, if you trace those rays backwards, those streaks backwards, they seem to be coming from the same place in the sickle of Leo. Fisheye view. If you're above the atmosphere, what does it look like from a spacecraft? And for our purposes this year, November 17th and 18th, we're talking late night November 17th, early morning November 18th is when Earth will pass within 243,000 miles of the dust trail that was shed in the year 1499. And the best time typically for viewing meteors is after midnight. And then if you're lucky, you might see something like this. It happens from time to time, obviously. Here's a photo of one. So you're going to go out in November, dress warm, keep some cookies handy, get a warm tarp, put it on the ground, look up, or get out your summer lounge chairs. But don't stand in your driveway with your head cocked back, because it's not good for your blood vessels and your brain and your eyes. Sit in a chair, better lay on a lounge chair, put a sleeping bag on the ground on a tarp, and enjoy it. So here's the well-dressed meteor. You can see a sleeping bag, looking back, a camera over here, maybe with the shutter open at various times. You got your basic cow in the field with you, some donuts, radio. The nice thing about the Leonids is, for the most part, I would dare say, we don't need this here. We don't need bug spray. Hopefully we don't need a snow shovel either. So there's some thoughts about the Leonid meteor shower. I hope that you get to go out. And you can go out a couple days, 3 days before or after the 17th, 18th, because there's a period of time that the meteor shower is active, but those would be considered the peak times, would be late November 17th or early morning on the 18th. But again, if it looks like the weather's not going to be good on those particular dates or not convenient for you, go out a couple, 3 days sooner or a couple, 3 days after, and you're still bound to find some. Well, let's take a look at how things look in the night sky, and I'll show you a little more about where the Leonids are going to come from. Well, hope that you enjoyed that little chat about the Leonid meteor shower, and let me point out, this is on the early morning of November 18th, which would also be the early morning of days before or after. 1 o'clock in the morning, this is the constellation of Leo just rising in the east, pretty much exactly east. And you can see in what we call the sickle of Leo here, is the radiant of the meteor shower. You don't have to have the radiant in the sky to see Leonids. Just look up all over the sky and you can enjoy meteors. You don't have to wait for the radiant to rise, but if it is risen, then you have more opportunities of a variety of meteors to be able to see. So we're looking east, and this again is early morning, November 18th. Now, next slide, we're going to go ahead to November 20th. And the reason I chose November 20th is to point out Saturn and the moon are really close together. But this is a whole lot more friendly time. We're talking 6 o'clock, right? And remember, daylight savings time, the first Sunday in November, we fall back. Okay, so it's going to be getting darker an hour earlier. But on the 20th of November, 6 o'clock, this is what we're looking at, the moon and Saturn. It's not a full moon. It's definitely less lit. And then if we were to go ahead to the 24th, you will find the moon is going to be hanging out by Jupiter. Okay, so remember, the moon moves from west to east about a fist's width. So if you put your fist right, I'm not sure I can actually do this, something like this, then the moon is going to show up the next day where your thumb is. So that's about 13 degrees. Okay, so now next slide, we're going to put on some lines here. So just mention some constellations that we're talking about here. So we have behind me is the Great Square of Pegasus. You see the 4 stars. And remember last month I showed you how to find the Andromeda Galaxy, which is right here. You take the upper left star of the square of Pegasus, 2 stars across, 2 stars up, and that's what I'm wearing on my sweatshirt, is the Andromeda Galaxy. I thought I might do that for fall, and this is my official Belmont High School Astronomy Club sweatshirt featuring the Andromeda Galaxy. Then we have Jupiter is hanging out close to a constellation that we know as Pisces, right? Pisces is the fishies from here underneath the square Pegasus, come down to meet with the other fish in here, and that's where Jupiter is. And Jupiter also is at the top of Pisces Australis, or the southern finish. The easy constellation to find is underneath Andromeda, and that's Triangulum, the triangle. Pretty easy to find. If you want to find the planet Uranus with binoculars, right between Jupiter and the Pleiades star cluster, we'll talk about another time, but between the Pleiades and Jupiter, you're going to find the planet Uranus, properly pronounced Uranus. Okay, next slide. And this just, again, gives us some pictures of some of the items that we're looking at. So we have Jupiter, and Aries is over where Jupiter is as well. Okay? And then Saturn is in the water bearer, or Aquarius, and the Moon and Saturn will be close together on November 20th. Okay? And next, finally, back to what you're going to see without any lines or artwork. And I hope that you can go out, and that you will go out and enjoy the night sky. Find Jupiter, find Saturn. The Moon is going to be there. One of the nice things about the meteor shower, the 17th, 18th, is the Moon's going to be setting around 10 o'clock. So we should have some moonless skies, if it's clear, to be able to see a good number of meteors. Well, I hope that you enjoyed the show. I'm Dave McDonald for The Sky This Month. Go out and keep looking up.